Okay, this is a quick update on the Season 1-2 speedometer board. Let's just apply power to the board, which is always a good start. And what we can see is a speedometer display in a 3-digit numeric and a 20 LED bar gauge associated with a diagnostic LED, which is on when there's no fault and will flash if the speed goes above a predefined value. Down here in the bottom left we have a trip meter, and we also have a 16 LED bar gauge, which can be configured if you wish as 2 individual 8-bit bar gauges. Also we have associated with those bar gauges diagnostic LEDs. When the bar gauge is configured as a single 16 LED gauge, the centre LED represents the diagnostic LED. When it's configured as it is here, with as 2 separate 8-element gauges, the 2 outer LEDs correspond to the diagnostic LEDs, and the centre one will be on continuously. Down here we have the odometer, which is reading 0 miles because we've just reset the unit, and we have a number of other LEDs indicating left and right turn and high beam, and some other secondary indicators that we use to indicate the state of various inputs to the unit. Let's go ahead and apply a speed signal to the board. It's quite a high speed. I don't think we'll be doing that kind of speed on the roads just at the moment, so let's bring it down to something more realistic. And you'll see the trip meter start to increment. These 2 gauges at the moment we have configured as a temperature gauge on the left side and a fuel gauge on the right side. Let's just have a look at how, when we vary these gauges, the diagnostic LEDs correspond. Obviously, if we bring the temperature right down, there's no low warning on the temperature, but if we take the temperature up off scale, you'll see that the left-hand LED corresponding to the left-hand gauge will start to flash and be associated with a short warning beep. Let's bring that temperature signal back into range again, and let's take the fuel signal high. There'll be no high limit on fuel, but if we bring the fuel value very low, we'll also get a warning beep, but this time the right hand diagnostic LED is flashing, indicating it's the right hand gauge that's gone off scale. Either one of those gauges can be configured to correspond to any one of a number of analog inputs. We'll look in a later video at the various configurations, but this video here is just to give you an update of some of the things that we can see in normal running mode. Let's use the left and right turn signals and see that they're represented by a green LED and high beam represented by a blue LED. So they just give you the kind of functions you'd expect on the dash. It is really useful, we feel, to have this gauge configurable as 2 separate gauges, because it allows you to display 2 of the most useful parameters, temperature and fuel, on the display at the same time. This numeric can actually be configured as well to display any one of a number of analog inputs, including fuel and temperature, but it's nice to see them as a bar gauge, so you can have this as a trip at the same time. You can see now that the odometer is starting to increment in miles. It's reading 3 miles. These are the whole number of miles, and these are reading down to tenths. Odometer and trip meter and speedometer can read in miles and miles per hour, or in kilometers and kilometers per hour. This little marker here is just an indicator that we're using for software development, so don't worry about that at the moment. When we shut the unit down, when we actually slow down and stop the car, you'll hear a short beep. That's, again, just something that we're using for software development, and the reason for that at the moment is because when you switch off the unit, you have to store the mileometer, the odometer, and the trip meter readings. And you can't go around doing that all the time, otherwise the EEPROM in the microcontroller would wear out. So we just do it when the car changes from a non-zero speed down to 0. So whenever the speed drops from a finite speed down to 0, we back up the odometer and trip meter readings to the EEPROM. Let's just put the power back on again. Sorry, the speed signal back on again. What else do we have on here? We have a number of secondary indicators to indicate various functions. Like this one represents power is applied to the ECM. This one represents that the ECM is demanding the fuel pump relay to come on. This next one here represents that the fuel pump relay output is active, and the final one represents the fuel pump fuse is intact. So if anything goes wrong power-wise in the electrical power to the fuel pump, we'll be able to pick that up on which of these LEDs are not illuminated. We don't actually have the legends and the transfers and the filter on this unit yet. It's not complete, but we're just giving you an idea of the functions that are implemented so far. Let's just switch those off, because when the camera is looking directly at the LEDs, they appear a lot brighter than they really are. We also have a few indicators down here. This one represents reverse lights, but you can use those to correspond to any high switched inputs. Also another one there for rear defogger and fog lights. So these are all high switched inputs which you can configure to anything that you want. And that is pretty much what the functional display mode does. As I say, there's a lot of options available which are set by various switches connected to the unit, or can be set by a USB serial bus connection, and we'll go into more detail of that in a later video. So let's just power down. There's that beep again to indicate that it's backed up the value to memory, and we'll just depower the unit.